Hi there, Andrew Jackson, AJ Design Studio. I've got another video here, third in a series looking at my exploration of variable pitch patterns in Solidworks. So, first two were first bit of exploration, trying to use a graph or a sketch to control the pitch of patterns, similar to functions found in some other CAD software. And I think I've actually found technique for mapping the pitch references onto curved faces, splines, and 3D space, etc., without having to go through, as I did in my second video, and capture a whole lot of dimensions as global variables, and then have to then go and control a whole lot of segments with those variables. So this, what I figured out is a way you don't need to use any equations, global variables, etc. It seems to work fairly well. There's a few examples here. This is a spline on a surface with just some revolves. So these are all using the same pitch tool over here, as you can see. So the pitch is wider and then it narrows towards the center and then widens again. This is a revolve using that. This is a helix, which I've run the pattern around a helix. Okay, so I will roll back up the tree. I'm not going to model this live because it's just a bit slow. So to start with, as I had in the other videos, I've created a pitch control sketch. So in this sketch, 100 wide, 100 tall, X and Y 100. I've basically, if you've got a straight line, anywhere there's a straight line, that means you can have a constant pitch. And then anywhere the curve gets steeper, the pitch gets tighter. And then as the curve comes around more towards the horizontal, the pitch gets increases. So I've got 3 segments in this sketch. So for this technique to work, the next thing I have to do is create a fit spline through those. So tools, spline tools, fit spline. So you basically select the 3 segments, convert entities from the pitch control into the sketch, and then make that into a single spline. Okay. The next curve is deform curve, because this technique uses insert features. I can't show you at the moment because uses the insert feature deform. We don't have anything to deform yet, so that's why it's grayed out. Okay, so this is my pre-deform curve. And I've created a sketch for a tool surface, which is basically 100 millimeter by 1 millimeter rectangle. And then I've made that that's a planar surface, so insert surface planar. Like that. Okay, so what I'm going to do is I'm going to, this surface is going to get split into my segments, and then I'm going to remap or deform this surface along another spline to create the pattern. So to split this surface, I need to create a tool that I can pattern. So in this case, I've created like a wedge, a skinny wedge with the point that's coincident to the end of this, end of the tool surface. And I've created a plane which is offset from that surface because I want to create a tool body, which is just the sketch for this planar surface, except offset up onto another plane. And then I've just created a simple extruded solid. And then I extrude that tool, as I showed earlier. Now the tool, when you extrude it, has to be longer then the y-axis of your graph become obvious in a second. So I've made that 110 long. So that is basically a wedge. Okay, and the wedge, make sure, this is critical, merge result is on and it's merging to our tool. So that way when I pattern this, we end up with a single body. We don't want to end up with a whole lot of separate bodies. Okay, and then, voila. So this is really simple. No segment tool in Sketch either this time. Curve pattern along curve. So I've edited this feature. You can see here the spline in my fit spline is direction 1. So that's the spline in the second sketch. You can pick the number of instances, and then the feature that I'm patterning is the wedge, and when that rebuilds, everything ends up as a single body. And you can see what's happening because that pattern is equidistant along that spline. When that gets projected down, you get your variable pitch. Okay, so just to show the flexibility there, pitch control on this end, maybe make that 20 degrees rebuild. Okay, so you can see the pattern is now going to bunch up this end. So there's a fair amount of flexibility in whatever. You could have a straight line, you could have several straight lines connected by several splines, so you could have even pitch, variable pitch, even pitch, variable pitch. I mean, it all depends on the application. Okay, so now the last step in this is I want to capture the each of these wedges onto the surface. So the easiest way I found to do that was just to insert a single split line between the solid body with all the wedges and the planar tool surface. If I hide that body, you can see there's my tool surface. Before I go into the examples, I'll just show you that you can, because the pattern, you can update the amount of instances, rebuild, and it all updates, and the split surface updates as well. So your pattern is captured on that tool ribbon surface. My examples will fall over because once you do actually start applying this to things, you do need to keep the same amount of instances, otherwise you have to redo. Like I've got sketch patterns down here, so I'm just going to reload this file. Okay, just roll back here, and I'll just go through how you apply the pattern tool to a spline or any curve. Okay, so I've just made a couple of copies using move body copy without a transform. Here I've created a spline, and then I've used Deform to remap the tool ribbon along that spline. You can see there that this the surface kind of deforms as it goes around that curve, and it twists. That doesn't really matter because the only thing I want to use is the points where this remapped surface lie on the spline. I don't care about this end, I only care about this end. So I'll show you how the deform works. So I've got that curve here that I mentioned at the beginning, deform curve, which is our straight line, 100 millimeters long. So that's our original curve, and the curve we're flying to, the target curve, is this one. And you can see which end it's remapping from this end along, from this end along. You can change that if you want. My pattern's symmetric, so it doesn't matter at the moment. And then you pick the body that you want to deform. So picking that body there. Now, when you create this feature, I believe the tolerance here on the shape options is down fairly low, so you want to turn that up on high. And the other thing is make sure you've got curve direction selected. In some cases, this will create intersecting geometry, and you can use surface tangent. You end up with this wobbly thing, and that works. But this one, curve direction, and hit OK. Just going to undo that because otherwise my revolve will fall over. So that's basically how you remap that tool surface with the splits onto spline. And this will update if I change the amount of instances in the pattern here. I made that 50, hit rebuild. The surface will rebuild here. You can see here my sketch has fallen over. That's because my sketch here was a whole lot of segments between these points. So I was looking for 30, it's lost those references. So if I undo, it's fine. And then I've just revolved that. That's the first example. Second example is cylinder, created a helix up there. To map this ribbon surface on, I had to convert entities of the helix into a 3D sketch, and then basically I used that deform tool again. Like before, you pick the pre-deform curve, 100mm, pick the target curve, pick the body that you're deforming, curve direction, turn the fitting tolerance up, and hit OK. And then to create this pattern, I've created a 3D sketch, which is basically points coincident to the relevant end of the ribbon. See that you can see it's deformed there, but it's only this point I'm worried about. The one that's closest to the target curve, I'm just assuming it's going to be the least deformed because it's closest to the original and target curves. Okay, and then I've just created a cut revolve and sketch pattern. So it's pretty straightforward. And last example, created a boundary surface, projected a curve onto it, and again had to convert entities of the curve into a 3D sketch to then use the deform tool to remap my my pattern ribbon. And then again I've thickened that surface and then added some cut revolves and added points for the sketch pattern and then sketch pattern like that. And these things update, so if I go in here, where's the projected curve? This curve here, it's getting projected on. I go like that, it will update. Because the 100mm curve is basically, it's going to spread the length of these across whatever length, like a length ratio, across whatever your target curve is. The spacing all happens automatically, which is nice. And then if I change this pitch control, 10, and rebuild, you can see what's happened there. So that's fallen over, but you can see it's fairly flexible, and it seems fairly robust as well. Yeah, so I've also taken this another step further just to have a look at something a bit more advanced. So over here I've created two directional setups, so two graphs. I've got a graph controlling the pitch of the pattern in one direction and then in the second direction. I'll just skip through this really quickly. So I've got direction 1 set up, which is in the north to south direction of the chair, and then east to west is direction 2. And I've imported an old surface model out of Rhino. Which I've just converted entities of the center line and the outside sketches, and then I've deformed these. Control, you can see there the pitch reducing down. I've deformed those along the center line, so they're a bit hard to see. You can see them there. And the outside, the other side, and then again for the top and bottom. And I've also thrown a third section through here, which is basically a plane intersecting with that imported surface. I had a few problems with these deformations falling over. That's why I mentioned earlier about maybe having to use surface tangent rather than curve direction. I'm not entirely sure why. Maybe the curvature was too great. So. And this finishes up with a boundary surface. So I've got this graph here is controlling the pitch along this way, and this graph here is controlling the pitch this way. You can see, and I've got a normal constraint along the center line just to make it a bit fuller. So with this sort of thing, with a grid like this, when I worked on the null generation chair and Pro Engineer, we created fibers with a variable pattern, with a variable pitch, in a similar way. So these curves, you can then remap them onto your target surface, or create sweeps through them. There's all sorts of things you can do. I just thought I'd show it in 2 directions. It's just interesting to see how this responds, you know. Let me see. So I'll change this pitch. It might take a little while to regenerate. Okay, so you can see what's happened there. It's bunched up more around here. So you do have a lot of flexibility. Doing this with face curves would be a real nightmare, I reckon. Yeah, been there, done that. Okay, so I've taken this a step further, created a gonna reload it, a 3D sketch pattern. So I created a point at each of those vertices, and then, like in the other examples, cut revolve, just one instance of the cut revolve there, and I've got a sketch pattern. Is that you can see all the points there, which marry up with the vertices, and then I've patterned that, which takes a little while to regen, and then mirrored it. Obviously not something that you'd see on the real chair. It's just an example of bit of a visual example of what you can do with this sort of technique. It's no magic bullet, but I put this together in about an hour. So, you know, once you figured a technique out, it's actually pretty quick to experiment and iterate. So, if you're an industrial designer, there'll be lots of iterations if you ever start doing patterns on things. So yeah, I hope this is useful for people out there. Been useful for me, because now I can move on. I've figured it out. All good. Andrew Jackson, AJ Design Studio. See ya.